Thank you so much for doing this. Okay, so here I've got some marbles. I've got some big glass marbles, I've got some little glass marbles, and I've got some magnetic marbles. And these are going to represent polar and nonpolar molecules. So which ones do you think represent the polar molecules?
The magnetic ones.
The magnetic ones. Okay, so if I dump out the magnetic ones, you see how they stick together? Okay, like polar molecules, just like water. Okay. Now I'm going to put in some nonpolar ones. You see how they don't stick together? Okay, so now let's suppose that I decide to mix things up. I'm going to put some polar molecules in there, and I'm going to put some nonpolar. Will they mix? What do you think? Will the polar and nonpolar mix really nicely? I hear some people saying no. Let's see. Do they mix? Not very good, do they? Okay. Now I'm going to take the little glass marbles. These are different. Are these polar or nonpolar? Nonpolar. Will these nonpolar ones mix with those nonpolar ones? Let's see. Yeah, they do mix, don't they? Okay. So now I have a mind experiment because I don't have any little magnetic marbles. If I had little magnetic marbles, what would they mix with? Would they mix with the polar or nonpolar? They would just combine with the polar when they stick to the polar. Okay, if I had some little magnetic marbles, they would do that. And so now that you know that, now we already remember what this is? What is this? We had it earlier. You can't tell by looking at the colors because the colors are all messed up because of this rubber stopper. Do you remember what this is? We had it like we were doing mixtures. It's oil and water. I know the water's got pretty skunky looking. And so is oil. Which one's the oil? Bottom or top? What? Top, because oil is less dense than water. And so it's floating. So we learned about density, but now you know why when I do this, it goes like this. Why is that? Why did this happen? Yeah.
They have different polarity.
Okay, so which one's polar? And so that means oil must be nonpolar. Okay, good. Here I've got some wintergreen alcohol. I got some water. Is alcohol more or less dense than water? Do you remember from earlier in the year? It's less dense. So let's see if it goes on the bottom. Did it go on the bottom? Did it go on the top? What happened?
It mixes.
Why did it mix?
Because of alcohol.
Because alcohol is
Polar.
polar. Okay. So there's a general rule of solubility. Like dissolves like. That means things that are alike in polarity dissolve things that are like themselves in polarity. Okay, so we can go just a little bit further than gasoline. Think about gasoline. Gasoline, are you supposed to put out a gasoline fire with water? No, why not? Because the gasoline will float on top of the water, and when you throw the water in, it just spread out. Okay. So what do you think gasoline is? Polar or nonpolar? It's nonpolar. So so gasoline doesn't mix with water. Would it mix with oil? Would gasoline mix with oil? Yes. Anybody have a 2-cycle weed whip or trimmer or whatever? And don't those have gas and oil mixed? Yes, they do. Okay, so there's a little bit about the relationship of polar and nonpolar. Got it. Thank you.